and in this video we're going to do 3 examples using Avogadro's number. In the first example, we'll be moving from grams to molecules. Let's say we have 141.8 grams of chlorine, and because chlorine is a diatomic molecule, it will be Cl2. The first step in moving from grams to molecules is to first convert to moles. Our Avogadro's number is a conversion through moles, so we're going to find the number of moles of chlorine. So 70.9 grams of Cl2 is equivalent to 1 mole of Cl2. So now that we've canceled grams, we can convert to molecules using Avogadro's number. 1 mole of Cl2 is equivalent to 6.022 times 10 to the 23rd molecules of Cl2. When we multiply this out, we find that that is equal to 1.20 times 10 to the 24th molecules of Cl2. Our next example will move from atoms to grams. Let's say we have 3.011 times 10 to the 24th atoms of mercury. Similar to the last one, our first step will be to convert to moles of mercury and then into grams, and we will do so again by using Avogadro's number. So to cancel atoms, we must put Avogadro's number in the denominator. Once we've canceled the atoms, we know that moles will be on top, so that is equivalent to 1 mole of mercury. And now that we are in moles, we can convert to grams using the molar mass, which in this case is 200.6 grams. So 1 mole of mercury is equivalent to 200.6 grams of mercury. Make sure everything is canceled, and we find that our answer is 1,003 grams of mercury. In the last case, we're going to go from atoms of hydrogen and find how many molecules of sucrose, or C12H22O11, we can form. So starting with 44 hydrogen atoms, we will use Avogadro's number to divide the number of atoms to find the number of moles of hydrogen, use the mole conversion to find the number of moles of sucrose, and then again multiply by Avogadro's number to find the molecules of sucrose. So in the first step, cancel atoms by multiplying by the moles over Avogadro's number. Now that we've canceled atoms, we're in moles of hydrogen. We will use the mole ratio, and we see that there are 22 moles of hydrogen in 1 mole of sucrose. And I'll just write SUCR, sucrose. And now that we are in moles of sucrose, we can multiply by the moles, Avogadro's number over moles to find the number of atoms in sucrose that we will have of sucrose. So 1 mole of sucrose times 6.022 times 10 to the 23rd atoms of sucrose. And you can see that we have Avogadro's number in the denominator and in the numerator. So to make it easier on ourselves, we can cancel these 2 out, leaving us with 44 times 1 times 1 over 22 times 1. So essentially, we're just dividing 44 or 22 from 44, which will give us 2 atoms, or 2 molecules, sorry, of sucrose. Thanks for watching and have a great day.